Welcome back to Air Quality Matters. We already have the tools and knowledge we need to make a difference to the quality of the air we breathe in our built environment. The conversations we have and how we share what we know is the key to our success. I'm Simon Jones, and coming up, a conversation with Chandra Sekhar, Professor in the Department of the Built Environment, College of Design and Engineering at the National University of Singapore, and ASHRAE Fellow and Distinguished Lecturer. It's funny how life goes. I've been talking to Chandra on and off over the last few years online. Then this year we got to meet 3 times in person, once in India, then last month in Montreal, and now as he passes through Ireland on a lecture tour. So it would have been criminal not to have taken the chance to sit down with him while he was in town and so close. He is one of the 3 pioneers who developed the Indoor Air Quality Research Unit at the National University of Singapore in the early 90s, and the team has since conducted research in ventilation and indoor air quality in buildings. Their tagline has always been energy efficient, healthy buildings, and through their collaborative research findings, they have made significant contributions to the understanding and enhancement of HVAC systems on the comfort, well-being, health, and productivity of occupants in tropical buildings. We had a wide-ranging conversation about a passion of both of ours communicating ventilation risk to users of spaces, but also about what lessons can be shared across continents through different perspectives and lived experiences. Chandra is truly one of the legends of this sector, so to get to spend a couple of hours with him was a real treat for me, and I hope for you too. A total gentleman, generous with his time, and after decades of work in this sector, still unbelievably driven to make a difference. Don't forget to check out the sponsors in the show notes and at airqualitymatters.net. This is a conversation with Chandra Sekhar. I think one of the problems we're having with air quality and getting it to land, because we get poor outcomes all the time, right, across the sectors, is that we've been seeing this as a engineering problem to solve, as a buildings problem to solve. And yes, it is in part, but it's as much a human-centred problem to solve, a behaviour, a habit, a culture problem to solve, isn't it?
Yes, there is. And I think what struck me at least the most was what happened during COVID. In the early days, there was a lot of concern simply because people were asked to go home, work from home. Nobody wanted to go to office or malls. And when you're home, you don't know what to do at home. There's not just one person in every home. It's still a small group of 4, 5, 6 people, depending on what the circumstances are. And I think what people really wanted to know then was, if we are home as a family or group of friends or whatever, there is still something that we need to take care of. And that part of the, I suppose, solution was not very forthcoming.
Well, here's a big question for you, right? And this is an infection control question, which I know is something you've spent a lot of time thinking about. Is the home a place for public health when it comes to infection risk? Because that's a question I've heard before. Public spaces, yes. Schools, yes. The workplace, yes. But really, when we start to send people home to isolate, are we just accepting that at that point that home, within that home, it's not about infection control once you get people into a home space?
Well, it can be seen in a couple of different ways, right? We go out in the open. That's outdoor air. So do we just leave everyone to the ultimate, consequence of what happens? I guess the outdoor air, some of the quality of outdoor air that one is exposed to is important, and it's not the person who is asked to be in the outdoor environment that needs to worry about it. I suppose there's a bigger social question that we are talking about. It may not be I guess that's coming under public health perspective in some way. When it comes to home, the way I would look at it is, if we are home, it's still part of an enclosed environment that someone needs to be, aware of and take care of measures that need to be done at the home level. You may have 5 or 6 people in a family, and sure enough, I mean, if one of them gets sick, or there is a vulnerable person, an aged person, somebody who is susceptible to getting infections, and we have something like an infection going on, I'm sure we would want to take some responsibility about what happens in that family.
And the dose is the poison, right, as well. Though we knew this from COVID, that the level of dose that you got of the virus impacted the severity of illness as well. So while you might not be able to eliminate risk in a home environment, you could certainly limit the exposure, the dose,
absolutely,
which could be critical for somebody, like you say, that's vulnerable.
Yeah. And I suppose what we are really talking about is if we can sort of, implement those solutions, those measures in, say, an office environment, workspace. Now with standards like 241, we are actually in 241, we're talking not just about work environment, workspace or office environments. We are talking residential. So the guidance that we are providing in 241 for residential setting is along the lines of what I just spoke about. So we are talking about if somebody is unwell, how do you isolate that person by creating a separation area? And that's part of the standard.
Yeah.
So we are thinking at a very different level of, let's leave who is responsible aside for a moment. If we look at what's important for the health of individuals, a home is a place where it's just for 5, maybe at most 8, 10 people. But then you collectively add all the homes in the world, that's your world population. So the impact is tremendous.
One of the things I liked, that's the wrong terminology, one of the things I liked about COVID, one of the interesting things about the global pandemic is the right way to phrase that, I think, is that it was a very concentrated period of time where people were focused on eventually air quality, right? And we might come on to that later,
right,
but air being a risk. And what I think it did was it put in the hands of the general population at home, for the first time, a sense of what the hierarchies of control meant when it came to risk and air quality. Because we started to try and eliminate the risk from a space. So people were asked to be separated from other people in the family, if possible. Right? That you had to introduce things like PPE. So like, I remember it when one of my daughters was ill, my wife, we had PPE equipment in the home. If you came in and gave them food and stuff, you wore masks while you were there. As you said, engineering controls, you opened windows, you started to take some control of your spaces about ventilating it properly. And I know people were thinking about ventilating their homes during the pandemic in ways they'd never thought of before.
Thought about.
I think it shows that with the right focus and the right terminology and communication to the general public, you can actually get them to start thinking about risk management. And what I think is interesting about this conversation, because I think the COVID conversation is obvious, but with the general air quality conversation, how do we get the general population to think in terms of risk and hierarchies of control on a day-to-day basis where they have agency over it? And I think that's a really fascinating subject. Getting people to think, can I eliminate some risks from my home environment? Are there things that I can do? Are there things that I'm bringing into the home that are unnecessary, that are introducing pollution that I don't need to? And that will vary massively across the world. We know India is a good example, and Asia, sage burning, sweeping of floors, habits and culture that introduce very specific risks.
Absolutely.
Because of habit and behaviour. In this part of the world, drying clothes indoors, incense and fragrances being introduced. Candles, these are their things. So starting to get people to actually go, you know what, I can actually have agency in outcomes here myself.
So I think you are hitting something very important here. COVID is about infection. infection risk. Let's take the other example of wildfire smoke. That's man-made, or sometimes, well, in some parts of the world it could be man-made. In other parts it is natural. Whatever the case, the outdoor gets polluted much more than what it normally is. Then the question is, what can we do about it in the indoor setting, in the indoor environment? I guess that's where, if people realize what it does to the health, the consequence of being exposed to the same level of pollution indoor, and if that awareness is high, they can certainly do something about it. Now again, if we think in terms of the solutions possible, we can talk in terms of an air filtration system, an air cleaner, air purifier. Or it may just be you close all the windows and stay indoor. That's probably the simplest thing to do. Then comes a question of then what happens to the indoor air quality. You have everything enclosed in a home setting, or for that matter any other setting, and you don't have any ventilation. That's also going to be an issue. So the question then becomes, what is it that one can do in those situations? Maybe in those kind of circumstances, you really need to have an engineering solution, which means making the building ready, for instance, right? So if you have a mechanical system with a good level of filtration in place, obviously that could be activated at a time when it is needed, like the outdoor is extremely polluted. So that's one way, I guess, the awareness has to be raised. We in Singapore introduced that in our standard in 2016, I believe it was. Again, it was a problem identified in our outdoor setting, not on a continued basis, but when we have the haze episodes. So the air gets very polluted, and if it prolongs for a long period of time, then it is an issue. So we did say in our standards that if you have those episodes, then your ventilation system, the outdoor air provision that needs to be done, has to go through we call it the MERV 14 filtration system. So we required buildings to actually have that high level of filtration in the event the outdoor air is polluted. So infection risk is one example we spoke about, and the haze kind of episodes, which is basically outdoor air pollution. And that can happen in many different ways. Haze, wildfires in North America, in Canada. When I was told that this year too they had some wildfires in Canada, and other places where it could be pollution coming from other man-made activities. So there are things that we are exposed to where we might just reconcile and say, I can't do anything about it. But if we spend a little bit more time and effort, we can actually address it. We can find solutions.
I keep going on about the hierarchies of control, but they're so apt for scenarios like this, because we've been managing risk in our environment for years, and these common sense strategies apply to everything. And there's a really good example. COVID, or pandemics, or wildfire smoke. Those are things where we can't eliminate or substitute those risks. They're going to be in the environment one way or the other in the right circumstances. So we know what to do in those circumstances. The next most effective measure is engineering controls. Is there things that we can do to separate ourselves from that risk physically, engineering wise? And that might be, as you say, simply shutting the building down if you don't have ventilation, or you don't have an ability to filter it, or introducing filters if you do. And then if you're limited or running out of engineering controls, then you're on to administrative controls. You're saying, right, what are the behaviours, what are the things that I can do to manage the risk in lieu of engineering controls? So the wildfire smoke is a good example. Can we give people the tools to balance risk in that space? At what point is it more risky for me not to have ventilation versus exposing myself to the particulate matter that's outside? How do I make that choice? If I have a sensor in the building, that's one thing, but if I don't, how do we as educators or people in this space provide people with the right tools to say, at what point do I have to make a decision that closing myself off from that risk is more risky than not? That's a really interesting subject. You're getting down to that because very rarely is PPE in the indoor environment an appropriate solution for managing risk, right? Very rarely in infection risk scenarios can we say, and some people within public spaces might make the choice to put PPE, but it really is the last resort. How do we provide people with the right roadmaps and tools, a bit like we did in COVID with the kind of Swiss cheese approach, where you do this and this and this and this and this, and whether you know it's the hierarchies of control or not, that's what it is. And you present that information in a way that people can understand it and make educated choices and how to deal with that risk.
Right. So I would say, I would go along with what you just said, Simon. What people need to be told and what they need to understand is exactly what we are talking about. There is a problem. These are the consequences if the problem persists. And if we expose ourselves indoor, let's talk about the example of the outdoor pollution. There is a wildfire smoke issue or a haze issue, outdoor is polluted. We can close all the windows and doors and stay indoor. And that's fine up to some point. Then we are talking about the indoor air quality being, affected in a way that you have no dilution happening, other contaminants are building up. And if we continue with activities that we normally do indoor, say in the home situation, we spoke about candles earlier, incense burning or cooking, all of this is only going to aggravate the matter further. If we identify these are the day-to-day activities that one is involved in, and in those situations, shutting the outdoor from the indoor by completely enclosing the indoor setting, we need to really have some engineering interventions. And this could be in the form of air cleaners, filtration system that one can just place indoor as a standalone room air cleaners kind of thing. Or if let's say if the awareness is raised to a level where we can go even one level up to say, can we have engineering control as part of the building system itself? What I would then call it as a building attached strategy. That would mean you somehow have a mechanism by which there is a fan and a filter, simply put, just a fan and a filter that is installed at the window panel, for instance, or somewhere if you have an opening for bringing outdoor air into the apartment or into the home at that point perhaps. So that is more permanent engineering solution. So we could again educate the population, the citizens, saying there's one thing you can do as a temporary measure if and when it happens, or you can say that you go in for a more, I would say, robust engineering solution as part of the building system, which is preparing the building for any times in the future. Today we're facing the problem of a haze or a wildfire smoke. Maybe you won't have it for 3 more years, 5 more years. But then down the track, over the next 10 years, 15 years, the entire lifespan of that building and that apartment, you are ready. When it happens, you got a solution. And I think that level of awareness, if it is then matched or if it is presented in a way that it is cost effective, how do we make that case? Health. We got to relate everything back to the health and the well-being. So if we are prepared for those eventualities in the future and we can take it as solutions at the building level, it is almost as if turning a fan on in a room, or you just turn the lights on when you need it. Exactly in the same way, we could activate this fan and the filter system when the need arises. So it needs to be there. We can't just have it in place in the building when the problem has happened or when the problem has started. So we can learn from experience, the past experience. There was an issue, the haze or wildfire smoke. At that time, we didn't have the solutions. You have temporary solutions, or you can do something about it for that particular season. But if you want a more robust system, then the level of engineering control can be elevated to making it more permanent as part of the building system.
Yeah.
So these are some of my own thoughts about how one could look at a problem happening outside is going to impact the indoor environment, and we can be asked, even as an administrative control, don't go out, don't do jogging, don't go for walks, stay indoor. But we can't just stay indoor all the time and let the indoor air quality aggravate. And that may not be the ideal solution, because we do have activities that we carry out that's also going to add more to the indoor contaminants.
My only concern with all of that, and I agree completely with you, but I always fear, because we say it in our community a lot, that we know how to build healthy buildings. Like these, most of the stuff we've described here is not high tech. It's common sense engineering, moving air, filtering it, basic stuff. But we think like engineers. That's, I think, a lot of our problem in this community. And the beauty of having the conversation around a people-centered approach, a health-centered approach, is that stuff doesn't matter so much to most people. Most people are fighting battles of their own every week about putting food on the table for the kids, keeping a job down, paying the bills, whatever the challenges people have. And the hard reality we have is ventilation and air quality just isn't high enough up in most people's agenda. There are circumstances where you can't see to the end of the street because of agricultural stubble burning or whatever's causing smoke outside, or you've got a global pandemic. But outside of those critical events, most of the time, most people won't think about the air they're breathing from one month to the next. And that's our big challenge.
It is.
You've got to combine somehow these practical solutions, which are clear in our heads. Like you and I could sit down and write on a piece of paper what we think the step processes were in various circumstances, and we'd be within a reflection of each other, I think, broadly. The challenges we have is that most people don't care enough. and I think that's the real challenge, is that when we put this out into the wild, when we start talking about people in homes, or even the vast majority of the workforce in the workplace, ventilation and air quality just isn't even a thing. And that's the big chasm we've got to cross somehow, is that people have got to think about this to care about it. And I think that's probably one of the great white hopes, really, of low-cost air quality sensors and this making the invisible visible for the first time in our lives. That we've got even if they're proxy pollutants, and we can go down all those rabbit holes, whether we think CO2 is the right thing or whatever, right? But the beauty is that we're able to display air in some form or other for the first time, practically.
Absolutely.
We just haven't been there in the decades before, and I think that's an exciting place, isn't it?
Absolutely. I forgot to get my sensor here. I wanted to. It's in my hotel room. So that's become part of my travel kit. In fact, become part of my daily life. I have it at home at my work desk. When I go to my office, sometimes I pick it up and keep it in my office. So what it does is, it's not that I wasn't aware of it before. I knew ventilation is important. But the fact that those kind of simple sensors can tell us one important piece of information, which is CO2, it's a proxy indicator about how good or how much of the air in which we breathe from is exchanged on a regular basis. So now the challenge here is, if the outdoor air is reasonable, we are okay to say what kind of exchange happens just for natural ventilation. You open the windows, there's an exchange happening quite normally, and that's not an issue. But if you close all the windows and you turn off any other system in the building, and you close the door, and in our climate, for instance, when we use air conditioning, it doesn't bring any ventilation. But when I look at my sensor, it will show me a reading of 2,000 parts per million of CO2. On other days when I'm using natural ventilation, it shows me about 500, 600. So what's the difference between the 500-600 kind of reading in my room at home as opposed to the same room recording 2,000 parts per million? I think that's a very important awareness raising.
Yeah.
That's an important educational element there.
I think for even people like us, it's a tap on the shoulder, even because you just, like, the hotel rooms are the classic, aren't they? We travel, you travel loads, I travel loads, and you wake up some mornings in some hotel rooms, you've had an awful night's sleep, and you'll glance over at the CO2 sensor and it's at 2,500 parts per million, and you join the dots.
Yeah.
And you just wouldn't have thought of that. Even someone that's in that space, you might just think, oh, maybe I was a bit warm, I'm travel, it's whatever. You'll think of everything else other than the air quality, but then you'll see, and all of a sudden you realise you've had terrible air quality in the space overnight, and maybe or maybe not that was the problem. I'm the same in my home office. Little behaviours in my home office, just cracking the window ever so slightly.
Yeah.
Makes a huge difference to the quality of the air in my room.
Absolutely.
And it requires. I have a camera. The people that see me on the podcast, I have various air quality monitors, because you can imagine, on my shelves behind me, and often I'm in meetings and I'll see them change colour behind me, and it's like a little tap on the shoulder to go, oh, you might want to open the door or let the dog out or whatever it is, just to change it. And that's what you need, that nudge, often.
Exactly. The other important thing that we need to educate and raise the awareness is also the fact that we need to breathe. We inhale and exhale, and that's life. For that to happen on a continuous basis, we are drawing this air from somewhere around us. I mean, we call that the breathing zone. That's where we're going to breathe the air in and we exhale into that same space. So the question about how good that breathing zone air is depends on where that zone gets its air from. It can come from outside. It can come from, a mechanical system that's going to provide a clean air to that breathing zone. At the end of the day, where we are in terms of the breathing zone is probably the most critical factor. So if you extend the logic of when you wear a PPE, then you are kind of just containing the so-called inhalation zone very close to the face. But typically when we're talking about a breathing zone, it's I always visualize it as something like a cylinder in front of me, around me, let's say. If I turn around, I'm drawing from this part of my body. Turn this way, I'm inhaling from this part of my body. The idea is that there is an immediate volume of space from where we inhale from. I'm not going to suck the air from the door there. I'm not that powerful. No one is. So we draw the air from the immediate breathing zone, which is how most ventilation standards do talk about in the air provided at the breathing zone. Now, to a person at home, to the ordinary citizens, all these breathing zone stuff may not really make much sense. But if we talk to them along the lines of what you inhale from wherever it is important, because it's going into your system, into your body, into your lungs. And that's critical. If that air that we inhale in is going to make us feel better, keep us healthy, if that message can go out and get everyone to sort of take ownership of, I breathe good, clean air, I will stay healthy. Yeah. And that's an important message to be sent out. And then the question of how do we educate them to ensure that they don't get exposed to bad air or poor air quality. If we connect the dots, not all the time they might be able to do something about making that air clean or good air for them to inhale from. But most of the time when we are, you spoke about earlier the fact that when we are home, it's not public space, it's our own space. But in our own space, what can we do about it? I think that's important to understand there. And the same question will go to the office environment or malls or transportation environments. It's that immediate breathing zone that is so critical, where the quality of air that we supply or we provide for is important for the person to breathe from and ensure that that process is always kept in a way that it is healthy for them. And it can be infection risk, it can be exposure to outdoor pollution, it can be exposure to other contaminants. The whole thing is so complicated. You close everything because the outdoor is polluted. We don't dilute the contaminants in. And then you got all the carpets, you got all the building materials emitting, outgassing. You are now inhaling another species of contaminants,
and
chemicals.
I think that's the challenge, though, with the human species, is we're not very good at compressing complexity into behaviour. That I think it's a real challenge in behavioural science, is getting people to understand particularly complex chronic risk, the kind of risks where I'm exposed to low levels of a whole range of things that in culmination might cause me a condition later on in my life. It's very hard for us to make value judgments in a moment on something that's so instinctive. I think that's one of the challenges we have with ventilation, is we're literally hardwired not to think about it. It's such a basic instinct, more than almost any other human thing, breathing, that it's something we can't think about. So in that context, how do we change behaviours that impact the big risk, which is the chronic risk? There's very few acute risks in air quality that are deadly, but there are many that are deadly long term. And that's something I've been personally battling recently, is how do we communicate that? And one of the thought experiments I've been playing with people that manage buildings in this space is to say, we have to recognise that our lungs are incredibly efficient delivery systems for pollutants into our body. And as such, that's why it's multisystemic, that they are a mechanism in which we can put pollutants into the bloodstream that are able to cross every cell wall in the body. That's why air pollution is associated multisystemically, right? So how do you translate into something that people can understand and relate to? And one of the things I was saying to people was, imagine every building in the world had an incredibly efficient ventilation system on the roof, and that ventilation system had a filter, and it was brilliant at filtering all of the chemicals and gases and particulates out of the air. It was absolutely fantastic. The only thing was that instead of capturing it in the filter for you to throw away, that filter put those pollutants into the water system of the home. So 24 hours a day, 7 days a week, those filters were capturing all the pollutants in the air outside and filtering them into your water, into the water you drank, into the water that you cooked with, into the water you bathed your children with. And there's nothing you could do about it. That's just the way buildings work.
Right.
You'd be freaked out, right? That every time you took a drink of water, you were drinking pollutants that were being captured from the air around you. Well, we have a system like that, and it's called our lungs. That's what our lungs are doing 24 hours a day, 7 days a week. There's only one thing we can do to reduce that risk, and that is remove the pollutants from the air. That's kind of what we're facing. And you can see people's kind of jaws drop when you explain it in a way where you go, well, we don't have a lot of agency other than to try and reduce the pollutants in the space, because this thing is happening all the time, and we're absorbing all of those pollutants every time we take a breath without thinking about it.
Right.
Those pollutants are being absorbed into our bloodstream, and accumulatively over our lifespan are causing premature aging and deterioration of cells and organs of the body.
Right.
That's just the way it is.
Yes.
There's nothing you can do about it. It's just the way that, I'm afraid, that's lungs do that successfully, because that's how we get oxygen into our system and get rid of CO2. So that's just the way it is. Why we take a Ventolin inhaler.
Right.
Because it's an incredibly efficient delivery system of that medicine into the lungs.
Right.
I haven't found a thought experiment that works for people that don't think about buildings like that, but I think we need to find ways of translating this stuff for people where they go, well, look, I can't think about this every day. So what are the habits I can introduce into my life, the behaviours, how and when I open windows, how and when I use ventilation systems, how and when do I spend my own money on what and prioritize on what, that I can, over my life course, get a better outcome. The kind of Luften, the German airing the home approach, that it becomes a cultural thing. I think that's a really interesting idea, and a very hard one to crack.
As I was listening to what you were describing, Simon, a few thoughts crossed my mind. I think when I see something, I register the impact. I know what the consequence can be. Even in the context of air quality, let me share something with you that I was exposed to when I was at college back in India. I actually studied in Jaipur. You've probably been to Jaipur, I'm not sure.
No, I haven't actually.
So Jaipur is a very hot and dry climate. We could hit temperatures in excess of 40 degrees Celsius. Humidity not so high, 10%, 20%. There could be time when it is more humid, but in the peak of the summer, it's very hot and dry. And then it's very close to the desert, so we would have storms, sandstorms. So I still remember one of those summers that I was there in my hostel. We used to go to a common place for our food. And when I walked into that canteen, or what we call the dining area, the table there was a layer of dust. I could see that. Now in hindsight, I know that layer of dust I could see is not the problem. So if you could see pollutant, right, that's the PM10 and above. It's the smaller size particles that are going to be floating around along with those big size particles that probably was already there in that environment. That if I inhale, I did inhale all of that into my system. So people do experience some symptoms. They would develop some kind of infection, or they might start coughing a little bit, some irritation in the throat. And if they see all that dust around, they can relate to it. Something in the air, I've been breathing that air, I'm getting affected. But the problem with even the dust and the particulate matter is the small size particles. They're talking about PM 2.5 microns, even the ultrafine particles that get formed due to other pollutants and other, reactions that happen within the building setup that we don't get to see. So if we don't see something, nobody's bothered about it. Nobody even knows about it. To me, that is education. That is awareness. We have to get the message across. What you see is not the problem. What you don't see is the problem. And this is exactly what is happening with particulate matter pollutants as one. The other pollutants, gaseous, all this volatile organic compounds. We have another, sensory approach we can use here, smell. Now, if you walk into a building and if there's been chemicals used, let's say brand new building with all the paints and brand new furnishings and carpets. Now, that smell, some people can see it as, well, that's the smell of something new, so it ought to be good. So I would counter the argument by saying, if you smell something, don't go for it. That's not the right environment you want to be in.
So poll 100 air quality specialists, and 99 of them are deeply suspicious of anything that smells of anything. I think that's the kind of. I was only joking with somebody that the other day who's saying, what are the kind of things you have done in your own home? And one of the big things we've done in our home is we have nothing with any fragrance in our home at all, because nothing that smells of anything,
right? So
that isn't supposed to be there.
Yeah,
is usually not good.
Good, exactly.
So actually neutral, when you come into a space like this, and I know this room can get a bit stuffy, but it's not full of fragrances and things. I was staying in a hotel there in a few months ago, and there was an issue with the air conditioning. It was smelling mouldy. There was mould in the very common, right, in these split air conditioning units in hotel rooms. So I went down, as I do, because I'm a hotel's worst nightmare now, because I complain about air quality more than any other thing in a hotel.
Right.
And I was saying, I think somebody needs to come and service the air conditioning in the room. They said, yeah, no problem at all. We'll be up with a fragrancer. We'll put one of those plug-in. And I was like,
Masking
no.
it.
Yeah, that's exactly what I don't want you to do. Add another pollutant on top of another pollutant so that you forget about the first one. So it's when you speak to air quality people, they're deeply suspicious of anything that smells.
Yeah. So I guess that smell being something that one can associate with. I suppose the messaging has to be, if you smell chemicals in your home, so in your workspace, where it's not supposed to be there, then something is not right. Yeah. And we're going to get the messaging across to say that these are chemicals, these are volatile organic compounds that have come from the building material, from the carpets, that are not good for us. And I think, again, raising the awareness that exposure to those kind of contaminants, gaseous contaminants, can affect our health. It has many problems and symptoms that people can associate with, or rather they would have been experiencing it, but not relating it to poor air quality.
I'd like to borrow your attention for just a moment to discuss ACO, a partner of this podcast. ACO, an EI company, specialises in pioneering new technologies in fire, carbon monoxide alarms, and Internet of Things technology. Many know them as the go-to company for these products. In fact, this year they're celebrating 35 years in business. I particularly know them for their outstanding work in the housing sector with their HomeLink offerings, aiming to solve some of the industry's most serious challenges. The technology incorporates environmental sensors and a gateway to offer connected home solutions, which has a proven track record in helping landlords reduce operational costs and carbon emissions while improving residents' well-being and safety. Issues at the heart of the housing sector, like damp and mould, fuel poverty, and energy efficiency, are all in the crosshairs of ACO. I've been amazed at how they are innovating here, with a laser focus on unpacking some of the complex nature of these challenges in a way that answers the what next question we so desperately need at the moment. They have a great network of experts and installers. If you're in housing, they are definitely worth talking to. Trusted is an overused word, but not here. Ask around, and ACO are synonymous with it. Details are in the show notes and at airqualitymatters.net and at ACO. That's aico.co.uk. Now, back to the podcast. One of the things you notice when you travel is that people's lived experience of the built environment is very different in different parts of the world. And you get very used to the European experience of ventilation and air quality, or very used to the North American HVAC experience. And, you're part of ASHRAE, you understand that mentality to ventilating spaces. And then you go to somewhere like Asia or the global South, and there's different experiences there. You've built a career in typically hot and humid climates. You've done an awful lot of work out of those areas. So there's a huge perspective and framing of how you manage indoor environments in those climates that's fundamentally different to our perspective and framing of how we think about our indoor environments here, and again, Scandinavia and northern climates. So I'm wondering if there's lessons that can be learned, both from how you think about spaces. So conditioning of spaces is a primary example of that. But particularly in a world that's also warming, where we're changing our approach to how we deal with our indoor environmental qualities. There are whole parts of the world now that are, if they're not implementing conditioning for the first time, they're having to start thinking about how they're going to implement conditioning for the first time as you get this creep of global temperatures. Are there specific lessons, do you think, from those climates that you see could translate and help us understand and frame in climates that haven't had to think about that?
Sure. That's a great question, Simon. I would look at it again from two perspectives. One is from a very high engineering perspective about some of the typical problems that we are facing in hot, humid climates for all types of buildings, residential, commercial, office buildings. So let me address the big engineering perspective. Energy is a big thing for us. If we are talking about air conditioning, energy is a big, it's a huge penalty if you're going to take a lot of outdoor air, simply because of the process that is involved in removing the moisture and lowering the temperature. It is an energy intensive process. So our approach right from the beginning has always been to do as much as we can with whatever we take from outside. So do more with less. So if you look at our ventilation rates and standards, they are not as high as what you probably have in Europe, and we are even a little lower than the ASHRAE 62.1 kind of standard numbers. Not for all categories of buildings, but in the main, we take that into account, the energy part into account when we specify ventilation rates. So there's a minimum ventilation we also have for us. Then the question is, how do we make use of that minimum ventilation we draw in from wherever the intake is and distribute it? We go back to the breathing zone. So that's the real challenge. In the past, our systems have been designed to, it still is in many buildings, where you have about, almost like 90% of recirculation and only 10% of outdoor air being taken in. And then it goes through the process of cooling and dehumidification, that is to remove the moisture. And then we distribute it into the occupied zones. It could be a high-rise building, it could be a commercial, like a mall, commercial building like a mall, or shops, or healthcare facility. You name it, all this high engineered buildings. I'm keeping residential away for a particular reason here. So high engineered building designs. So what happened then was the indoor air quality. We started our research in this indoor air quality field back in the mid 90s. My colleagues and I, we were three of us. We started this indoor air quality research in our group, in our department. At that time, the whole understanding of indoor air quality was in its infancy in Singapore. And we did some studies, we collected data from the buildings, and we were able to, identify that when you have good ventilation, some of the indoor contaminants were kept low in those buildings, like the chemicals and particulate matter and formaldehyde and all those sort of numbers. And we were also able to find some associations with people finding a well-ventilated building to making them feel good, making them feel healthier and better in terms of acceptability. So there was all those clear associations. Good ventilation, good indoor air quality means people were happy, they were comfortable, they were satisfied. So that was like the very early set of data that we got. And then we also noticed something very unique to tropical buildings. A lot of people would say, your buildings are too cold. And it indeed was. Many buildings were very, very cold, designed as overcooled buildings, operated as overcooled buildings. And my take has always been, it's probably because when you have a cooler environment, maybe your response to some of the contaminants is not that severe as compared to when it was a little warmer. What I mean by that is when we breathe in air that is colder or cooler, our olfactory senses doesn't distinguish between poor air quality and good air quality. It kind of provides this masking effect.
Yeah, I was going to ask you that because it was that's an important distinction for people that aren't in this space to understand, is that a lot of the human response to stuffiness, which is overly warm, smells, odours. I think most people can picture what it feels like to walk into a stuffy space.
Right.
When you condition a space quite aggressively, you take away some of those human indicators,
Right.
don't you? And I think most people get that feeling, particularly when they're on holiday, say, and they're not used to hot climates. You go into an air-conditioned space and you're like, oh, that feels fresh and lovely. You know, you feel like it's a relief.
Yeah.
But what you're doing is masking potentially some of those human responses, aren't you?
So we found in our studies and our research that, people's acceptability of indoor air quality was very closely associated with their perception and satisfaction of the thermal environment. You walk into a building, if it's cool, nice, comfortable, then you're almost always going to say the air quality is pretty acceptable. If I took my sensors and made the measurements, it would still show high contaminant level. Example of split system units, CO2 levels 2,000-3,000 ppm, obviously has to mean the other contaminants are equally high. But we don't complain so much about those environments because it is relatively cooler, masking effect dominates, and we accept it. Now, going back to the engineered buildings or properly designed buildings in the past from our research, we realized that yes, there is a huge energy penalty for cooling and dehumidification, and also the fact that we are not taking in as much ventilation air, outdoor air for ventilation, as you probably do in some parts of Europe and elsewhere, at least at some times of the year when the outdoor is what we call just nice, right? You don't need to cool, you don't need to heat, you just take the air and move it into the building. What is in engineering terms called as economize the cycle of operation. That's not energy intensive, but you're getting a lot of outdoor air to flush the contaminants from within the building. We seldom have that opportunity. Our outdoor air is always challenging. We would never have the luxury of taking the outdoor air and putting it through the building as a 100% system, outdoor air system. We would always have to cool and dehumidify, and that's energy penalty as we discussed. So the question that we asked in our group is, what can we do to make that outdoor air work even more? How can it serve us even better? Then the discussions go along the lines, also in collaboration with our colleagues from other parts of the world, we realized that it's the breathing zone that matters. We don't have to ventilate and make the entire volume of air in the room as clean. It's the air in the breathing zone that matters. So we then said, okay, let's decouple the ventilation from cooling. It's this combination of taking a certain amount of outdoor air, mixing it with the return air and treating that was not being very efficient, not being very effective. So we went on the concept of separating the ventilation from cooling. That led us into a very significantly different type of HVAC design concept. So we were then talking about, let's just use the outdoor air for ventilation, and then we can do the cooling by other means, and maybe we can even raise the temperature of the background air in the room. So we moved from, for commercial buildings and office buildings, we moved from single duct or one duct system, which moved outdoor and recirculator combined into two separate tracks, one for the ventilation, another one for the cooling. Now, the cooling does not necessarily have to be an air-based system. It can be other means. We then went on to look at things like personalized ventilation. Is something that I can talk about, where we realize that you get that outdoor air, the clean air, very close to the person's breathing zone. And that's the best you can do. I mean, you're providing what each person needs in terms of his clean air in the breathing zone, directly where it matters.
So there's a couple of things I want to backtrack on there, because I think you touched on a couple of really interesting ideas. The first one was this: buildings actually, when we asked people, could be too cool, right? And I know there's some building or refrigerant physics that go on there as well, where actually it's quite energy intensive to dehumidify the air, cool it, and then actually reheat it again to a certain degree to make it comfortable that you're not getting cold air. That actually there's a process of cooling and reheating if you're actually controlling air conditioning effectively to make it comfortable. And that's why often a lot of air conditioned spaces are too cool, is because they're not actually thinking about that reheating part. There's some really technical bits to...
It's not so much the not thinking about reheating. In Singapore, we're not allowed to reheat.
Okay.
So we are not allowed to use active reheat in comfort air conditioning. Energy penalty is acknowledged in that kind
really
of
interesting. Okay.
requirement.
So in order to get it cool enough to get it to dew points to dehumidify it, that's one energy block. But actually to reheat that again without the moisture to a comfort point carries an energy penalty with it that's not allowed in climates where you just have
comfort
air conditioning. Really interesting. But the other thing is that then when you were asking people in those spaces, you were like going, well, actually, it's too cold for us, or we'd be happy with some adaptive comfort here and being a little bit warmer.
So we'll come to that part. So a couple of things I would like to talk about on the point that you just mentioned here. Overcooling happens because we want to get the moisture out. And then we are not allowed to reheat for comfort air conditioning because it is additional reheating energy penalty. So a part of our research over the years, that's where I did my PhD as well, it was to do with the cooling coils and see how best can the coil be designed and operated so that you get the most in terms of heat and mass transfer. This is getting a bit technical, but let me say it nevertheless anyway. So what happens is, if the surface of the coil, a cooling coil is basically like a radiator with tubes and fins or extended surface for the heat transfer and the mass transfer to occur. So we realize that if the surface temperature is kept as cold as possible, you get the maximum condensation. That's logical. Colder the surface, more condensation. How can we operationally keep the surface cold? And that's a technical question. That's a technical challenge because the cooling loads in buildings are never the same. It'll fluctuate. It'll vary from morning to evening, vary from month to month, day to day. So it is a given that things will not be constant. It'll change. And if we over-design, as is customary in designs and buildings, you have a very large cooling coil. You got a mechanism by which you modulate the chill water flow, and then it reduces to an extent that hardly any chill water goes through it. So the point that we realized very quickly in our research is oversized cooling coils are one of the big problems, the reasons why we are not able to achieve good dehumidification. We then went on to look at how can we make a large cooling coil work differently in the operating stage, in the operation of the cooling coil. So we actually developed this system or this technology, so to speak, where a 6-row cooling coil can effectively become a 4-row coil or even a 2-row cooling coil, depending on what the cooling load is. And the smaller the coil is operated, we are able to maintain the surface temperature the coldest. And we do that by the modulating valve that keeps reducing the chill water flow. We are able to bring it back to the design flow rate. And that means the water velocity is an important factor. This is getting a bit technical, but I think it's interesting to understand.
Well, this will be chaptered, so if we're losing people, they can skip to the bit where we start talking about engineering.
So basically, it's to customize the operation of a cooling coil based on the demand.
Yeah.
And we have a technology, or we have a strategy by which it can be done pretty much in an automated manner.
I was going to say, is that an old problem now? It's like, I mean, because you've been conditioning spaces in hot and humid climates for a long time. Right. I take, there's a lot of money in the manufacturing of conditioning units in those spaces.
Right.
I'm assuming that a lot of these questions over the last 30 years have been addressed.
Have been spoken, about and have been discussed, debated. So overcooled buildings are now not very much popular.
Yeah.
Many of the existing buildings are also operated differently. We have campaigns like go for 25 degrees Celsius, not the 23 degrees Celsius. So increase the temperature set point. So the long and short of it, Simon, is we are moving away from very cold indoor environments to a slightly warmer environment. Warm doesn't necessarily have to mean it's uncomfortable, because we make use of moving the air speed, using ceiling fans or pedestal fans or desk fans to provide that additional cooling effect at a slightly warmer temperature. This is part of adaptive comfort, if you want to say it that way. So we have very good examples in our own campus buildings. I'm not sure whether I have spoken to you earlier. I can just talk about it very briefly. We have a brand new, it was brand new 5 years ago, but it is very much in steady state operation now. It's called SDE4. It's Singapore's first purpose-built net zero energy building, designed as such. We are very pleased to know that the building is producing more energy than we need. So it's basically it's got photovoltaics on the roof of the building, and it produces. It was designed to produce enough to make it net zero, but over the years it's been producing a lot more than what we actually need. So it's a very good success story for us, and it's actually become energy positive building. What does it mean in terms of the thermal comfort and the indoor air quality? It's another interesting story. We maintain the space at 26 to 27 degrees Celsius. We only supply 100% outside air.
For my Irish listeners, yes, he did say 26, 27 degrees. The melting point of the Irish is 23 degrees. It's a joke,
Right.
but we start to fail to work properly.
23 degrees?
But that's what I mean about different perspectives. You know, the thought of an office space design temperature being 26, 27 degrees is an anathema.
But you probably don't like air movement.
Yeah.
That's my experience. Yeah. Having many friends and visitors from cold climates, Europe in particular, they don't like air movement simply because they think it's giving them a sensation of draft.
Yeah.
Unlike in the tropics, tropically acclimatized people, we like air movement.
Yeah.
So 26 degrees, 27 degrees, when I got an air speed of, say, 1 meter per second, it's actually pleasant. And that's part of the adaptation that we talk about in the tropical settings. So increasingly, many buildings are being designed to go 26 degrees airspeed.
And that hits my first point of the original question, actually, is about the lessons from climates as we start to adapt in climates that haven't traditionally had to condition spaces. That actually that could be one of the tools at our disposal is air velocity, air movement in spaces. Before we move to to air conditioning units and split units in the residential sector,
right?
What's wrong with ceiling fans?
Yeah.
You can create spaces. You think of the Mediterranean have managed their spaces over the years. It's been with stack ventilation, good amounts of purge ventilation and ceiling fans.
Yeah.
And you can maintain up to quite high temperatures, pretty comfortable conditions with those basic without actually having to get conditioned spaces.
Yeah. So this is a good place for me to talk about the second type of buildings I want to talk about, the residential setting. Buildings in the tropics, not just in Singapore, anywhere in the tropics, including many African countries, are designed as naturally ventilated. I see natural ventilation as being assisted with fans as mechanical ventilation. Pure natural ventilation with no fans is probably a little bit challenging for us. But our residential buildings are naturally ventilated. It is never designed as air-conditioned buildings. So we have, design requirements, or we got to have so much opening, so many windows in the house, in the apartment. But almost always, you're going to have fans. It could be ceiling fans, it could be pedestal fans, any types of fans. So fans in homes in the tropics is a given. No question about it. What had not happened in the past was people said, okay, I have fans. I will use fans. I can put in an air conditioning unit. I will use the air conditioning unit. They never thought about linking the two and making the two work together. And that is where there is tremendous opportunity to operate an air-conditioned room in the residential setting at a higher temperature and using the fan we just spoke about that short while ago, and the fans to provide that air movement, and it's very comfortable. And I do that all the time. I've been doing that. My family, we've been doing that for, I would say, at least 15 years, 20 years now in the residential setting. Then the question is, why can't we use that in commercial setting, in office environments? So I guess the fundamental question here is adaptation and acclimatization within the indoor setting, be it residential setting, be it office setting. Let's make use of more energy efficient ways of giving us the same level of comfort. We're not even talking about air quality here yet, but it's about comfort. Remember, we said comfort is closely associated with air quality. People's responses pretty much aligned with that. Now, in the office setting example I just spoke about, we don't recirculate the air. We don't recirculate any part of the 26, 27 degree air. It's a single pass system. We have a dedicated outdoor air unit that just treats the outside air and supplies it as airflow into the space. And the fan does the rest of the job. It provides an additional additional cooling effect. Not cooling, but cooling effect, convective cooling effect.
Is it pretty automated in the campus? Is there some agency involved as well? So are people using desk fans and ceiling fans and turning stuff on and off, or is it completely kind of background?
It's not in all the buildings.
Yeah.
It's in this particular building that was designed as a net zero building, which has this kind of an air conditioning system assisted with ceiling fans. We have an array of ceiling fans, a grid of ceiling fans in the spaces. Now,
and people choose to turn those on and off, or
yes,
they're automated.
They're controlled zone wise. So if you have a large, say, an architectural studio space, you could divide that into 4 or 5 different zones, and each zone can be controlled separately. The ceiling fans, as well as even the outdoor airflow supply, the basic air conditioned air that is provided to that space. Now, what we have also been able to do is we have adopted that same technology or strategy in a couple of our old buildings. So we have a 50-year-old building, 2 50-year-old buildings. Our options were either pull it down and build a new one, or retain those 2 buildings. So you keep the embodied carbon stuff in there, and it gives you a much better conversation to talk about. And then we adopted strategies like elevated temperature and elevated airspeed to go with it. Of course, we had to address the air tightness of the building. So the facades were redone, so to speak, with the window panels being made more airtight. And basically, we did the facade pretty airtight. And then introducing systems like single-pass outdoor air system with higher temperature and ceiling fan to provide that cooling effect. That's also giving us the same net zero energy kind of a story to talk about. So we currently have in our own college a brand new net zero, actually it's an energy positive building, and 2 renovated or retrofitted buildings that are net zero design, net zero operation.
Yeah, so it shows it can be done. One of the interesting things you mentioned as well, and I didn't want to skip over it, was this separation of conditioning from ventilation, this idea that ventilation for the purpose of air quality, conditioning for the purpose of thermal comfort, and while they might interact, they are separate and distinct in their purpose. That's quite an important distinction, isn't it? Particularly in spaces we start to condition. And that's a question I know that we're starting to have here. but it's in reverse. What we get asked here in this part of the world more frequently is what's ventilation's purpose in thermal comfort, or particularly for overheating events or, heat wave events. Mm-hmm. And there's only so much you can do with air movement to cool a building down. So there's a limit to that. Right. So it is quite an interesting concept when we start thinking about these conditioned spaces, that there's potentially air movement or not for conditioning, but there's ventilation for the purpose of air quality, distinct from that.
Right.
That was something that you really looked at in detail, wasn't it?
When we see it as ventilation and cooling, the air that's used for ventilation does some cooling, no doubt, right? And the additional cooling, if you need it, you can do it with other air or room air or recirculated air. Now, what we are able to see in the net zero building that I spoke about, we probably don't need more air for cooling. If we take the view that thermal comfort is not just about temperature, but there is a temperature and airspeed effect that provides us that combined effect as thermal comfort. So that's part of the story that we are talking about. But to your point about the ventilation and the cooling, if we focus on the ventilation air to be provided to the space, to the occupants, the breathing zone of the occupants, that is what we need to do. That's what designs need to really address. Where we lack to do that, the residential setting, we just go for thermal comfort. It's the split system units. Somehow that has not, taken into consideration the need for ventilation. To me, ventilation is with outdoor air. I see, maybe I'm a HVAC person. I see ventilation as something that's required for air quality. Of course, it does the comfort too, thermal comfort part as well. But to me, primarily, it is for air quality, dilution purpose. So it's outdoor air that is conditioned, clean, filtered, and all that kind of stuff. So if we do that for the residential setting as well in a meaningful way, then so we can improve that situation too. But I guess buildings are designed as naturally ventilated. Now let me talk a little bit about the residential setting here. Buildings in the tropics, we're talking about all the Southeast Asian countries, India, Africa. That's a huge belt. Almost like 2.5 billion people are covered in this belt. Now, we can't be advocating air conditioning to all these people, right? It's too much of a challenge. It's too much of suppose even an energy implication, and maybe it'll not be easy to implement it. But what we can do is to ensure that the ventilation is taken care of. The ventilation here meaning the outdoor air provision to the indoor settings, and using the ceiling fans or pedestal fans to provide that additional comfort feeling. And I think we spoke about that earlier in the conversations. I mean, if you remember, we were talking about having the outdoor air is polluted. What can you do to bring that clean air into the space? If it's too much of a problem to do that, we can have local means of cleaning. So all these are strategies that can be, in my view, it has to be better presented and better implemented in many of the naturally ventilated settings. We are beginning to do that, but it's not done to an extent where we can, say that, all buildings are pretty much, equipped to handle situations of different types of emergencies. Now we can go back to the haze or the infection issues.
And particularly in developing countries, access to better air quality is often an economics question as much as it is an engineering solution problem. We in the same way, sustainability is an economics question for a lot of people, is that you've got to put people in a position where they're able to afford to take care of their health in the first place, or afford to decouple themselves from certain energy sources or whatever it is, if you're thinking about sustainability. So these questions can run deep and be very complex depending on where you're viewing this from. So, we're talking about advanced buildings in Singapore and European mentalities to ventilation, but in many parts of the world, a bathroom fan is a luxury potentially, like you have to think in terms of how, when we think about global strategies, and I know you and I had this conversation at the UN event there a few weeks ago, that, when we talk about air quality being a human right, we have to think about this in the global sense. That this can't just become a Western global South divide, that it has to be, we have to be able to think in terms globally when we talk about air quality, don't we? And particularly things like the residential sector, that's a huge challenge.
It is. It can't be seen as a very expensive engineering solution that becomes like a bottleneck, right? If you don't have the money to do it, nobody's going to do it. But we got to find ways and means to get people to realize there are still certain things they can do in very simple terms, and that's the challenge, right? That's the it's almost like saying that you can't have all the good things that you're thinking about done and implemented in a very simple way. There is a cost to it. Now, I suppose, I guess it depends on how one looks at it. There's a cost to it, can be seen as, if you don't do anything about it, the cost to health. That's a different kind of cost we're talking about. That could be very expensive eventually. And that goes back to what kind of health ecosystem we have in any type of country. But I think prevention is better than cure. So if we can focus on what can be done in very inexpensive, simple ways, I'm not saying it can be done completely without any investment. There probably has to be some level of investment, but it need not be so prohibitive that it becomes, I don't even want to look at it because it's so expensive. So we can find cost-effective means, cost-effective solutions that can be implemented for this 2.5 billion people that we're talking about, especially in the residential settings. I can even relate to things like, we have many parts of the world where we have rural settings, community settings, where their livelihood and their main source of cooking is burning wood, solid fuel combustion. And if you burn wood to make all that, the cooking part of it, and it's typically done in environmental settings where, again, you don't have good ventilation. And you got those settings like in a hut or in huts in a small village or a community where the women who are in the home cooking and little children with the women, with the mother, they are the worst affected. So this is a well-known, well-understood problem. And I think there's a lot of effort being done to probably change the cooking habits to go into more pollution-free means of cooking, like gas stoves.
I was talking to Priyanka Kulsheta from SEI in India, and they did a lot of work around that, I remember. So directing resources into reducing the cost of gas cookers makes a huge difference. So as a return on investment for spend, it is huge, because it doesn't cost much to reduce the cost of gas cooking for people, but the impacts on long-term health are absolutely enormous.
Absolutely.
So intelligent spend on resources can make a huge difference, because there's some enormously low-hanging fruit with certain habits and activities that you can have big impact. She was talking about, for people that know what this means, people with PM exposure 2.5 of 3,500 micrograms per meter cubed, basically directly over solid fuel cookers, like just mind-boggling amounts of particulate matter. But if you think about it, anybody that barbecues on a weekend or sits around a fire camping, like, there can be a lot of particles around when you're cooking on solid fuel.
Yes. And I guess whilst we are looking at making the transition from solid fuel combustion to more cleaner fuel usage, there will still be a sizable, I suppose, population that will continue to be using solid fuel combustion. In the interim, what can we do about it? This conversation is not new. It's been happening, at least in my understanding, for almost 20 years. It's still work in progress in many parts of the world. So there is still a huge population that's dependent on solid fuel combustion. But I think as an engineering solution provider, we know what can be done. We know those little settlements, huts, can make use of ventilation to make that environment a little better for the mother and the children and for pretty much all of the residents of that place. So how can we introduce the concept of, I'm not talking fans here, I'm not talking exhaust fans, I'm not talking about any mechanical filtration system. Simple ventilation strategy. We can make use of stack effect. We can make use of naturally moving chimneys, or vents rather, not chimneys, fans on top of chimneys, so to speak. So there are so many of these kind of simple solutions, low-hanging fruits really. But there has been no concerted effort to take this message to that group of people who really need it. They won't even be aware of anything like this as a possibility. Yeah. So who is responsible, or who should take ownership of that population, that group of people whose lives can be made better by very simple interventions? And I think that's where, if I had the time, perhaps after I retire, I would love to be involved in something like that, where, simple concept of ventilation that can be done through just reconfiguring the way that cooking is done. You're still using solid fuels because we're not completely eliminated that as a technology for them to work with. Just changing the way the chimney is designed or even made for that particular settlement, and have some means of ventilation, exhaust ventilation, not electrically operated, just natural buoyancy. Yeah. As the hot products of combustion go up, it can start to move those ventilators, and you just have a natural flow of air from down below and through up at the top.
That kind of low-high ventilation works in all sorts. I'm into and we're going to run out of time, which I knew we would, but what's pushing your buttons now? I mean, you've been at this air quality game now for 35 years. You clearly, I can see there's a twinkle in your eyes still about this stuff, that you're still motivated. What are you getting excited about at the moment? Because I've had this conversation a lot. I feel we're in a funny space in the ventilation and air quality space at the moment. We've come out of a global pandemic. I think people expected a shift that hasn't transpired somehow. There's definitely a different kind of awareness than there was before, but I don't feel that we're in a fundamentally different place than we were 8 or 9 years ago. But technology is moving on, standards are moving on. You were involved in 241. We had Bill Bonfleff on there last week. So things are moving on, but we're still in a funny place. What's motivating you at the moment in this space?
To me, the big motivation is how to get people, ordinary people, to be able to do something about their environment, immediate environment. And I'm personally motivated by the fact that after pre-COVID and post-COVID, the awareness has risen tremendously. And if that can be continued, and people be made to realize that good indoor air quality is important, there are things that we can do on our own. Yes, the engineering side, the technical side, the policy and standards are going to happen. And I think, the part of the messaging that I would like to do, and many of my colleagues are doing through 241 and elsewhere, is the fact that we need to prepare our buildings for the future. Building preparedness is a very important aspect of what we want to do, and making our buildings more resilient. I think these conversation topics are becoming rather easy to do now. So that's my motivation. Pre-COVID, I would have struggled to convince anyone about personalized ventilation, or trying to talk about you need to ventilate a building or a room. Not to everyone, but a vast majority may not even want to have those conversations. But once we raise this awareness, you got to be in a well-ventilated space. You got to avoid crowd because, a lot of mixing of air from many people is not a good idea. So that's ventilation, indoor air quality. It's become easy to have these conversations. When I started my career 35 years ago, there were only a few of us like-minded people talking about indoor air quality and ventilation. And we were seen as, okay, you guys are doing something that you think is good and important, but, the reality is not everyone is aligned. In today's context, I think I see alignment. I see many people across different societies, different dimensions, be able to appreciate what is required. My concern is people are beginning to lose sight of what happened 5 years ago. And I keep reminding them, look, what we went through as pandemic is not once upon a time. It just happened 5 years ago. It can come back anytime in any form. We don't even have to wait for something like that to happen. Let's talk about seasonal flu situations. Let's talk about an occasional, poor environment in any building or any part of the world. We should be very quickly able to think along the lines of, here is an issue about indoor air quality. We know a lot of things that we can do. How can we make it happen? So to me, science and engineering into practice, I think that seems to be the way we have to accelerate this whole process forward. And I'm inspired and motivated by the fact that there is alignment. It's not difficult to have this conversation with anyone for that matter. I can talk about this to a school kid. I can talk about this to a college kid. I can talk about this to you, to my professional friends, my colleagues. I can even discuss this to someone who is sitting at home, retired, reading newspapers or watching television, and still the point will be made that the indoor air quality is so important. It affects each and every one of us on this planet. And that's the beauty of it. I mean, apart from the fact we spend more than 90% of the time in indoor settings and all that stuff, it is really the fact that people are beginning to realize how important and crucial it is that we need to have good, clean air that we can breathe, and that's going to help us live a healthy life. And that, to me, is really the motivation of it. There are so many other technical stuff we can talk, but I think it's the alignment. It's the alignment in a post-COVID world that has raised the importance of good indoor air quality and the possibilities of different kinds of challenges like pandemics or outdoor air pollution or a combination of both. We were fortunate enough in our part of the world, and most parts of the world was quite lucky that you did not have a very severely polluted outdoor environment like a wildfire or a haze and having to stay home.
Yeah, very interesting. Well, Chandra, it's been fascinating talking to you. I know you're on a bit of a European sweeping tour with your distinguished lecture series with ASHRAE. So thanks a million for taking a couple of hours out to spend time talking to me. It's been an absolute pleasure.
Thank you, Simon. Thank you for having me. Really appreciate it.
Thanks for listening. Before you go, can I ask a favour? Before you shoot off to whatever it is you have to do next, or even the next podcast, if you enjoyed what we've been talking about here, please do spread the word and let's keep building this community. And don't forget to check out our sponsors in the show notes: Ultra Protect, Eurovent, Erico, ACO, Farmwood and Zender, all amazing companies, and without them this podcast would just simply not be possible. Check them out in the show notes at airqualitymatters.net, and do check out our YouTube channel. All this content is there, plus much more. See you again next week.